Alright, in this section we're going to talk about quadratic functions. Okay, so the graphs of our quadratic functions or our parabolas, again the axis of symmetry is going to be wherever the vertex is located. It's going to be x equals that value. If the parabola opens down, we say that's a maximum value. If the parabola opens up, then we have a minimum value. Quadratic functions that are in the form of ax squared plus bx plus c. We also know them as parabolas. They create the U shape on the coordinate plane, and they are symmetric to the axis of symmetry. Specifically, if they're in standard position like our parent graph is, like we know the parabola to be, they're symmetric in respect to the y-axis. So one more time, our parabola is going to open up. If our leading coefficient is positive, our parabola opens upward. If it's negative, then our parabola is going to open downward. Okay. So in this example, it says graph the parabola by plotting points. So this should read f of x equals 2 x plus 1, and that's being squared. So if we remember that from our transformations, we know that this graph has moved left 1 and it's been stretched by 2. The instructions here are telling us to plot using points. Because I know it's moved left 1, I want to create a table of values where I'm evaluating it around that vertex, the point which we moved to the left. So I'm going to pick -2, -1, and 0. And that should be enough to see the curvature to this parabola. I know that it's going to open upwards because the leading coefficient is positive. So when we input -2 in, we get -2 plus 1, -1 squared. That's 1 times 2 is 2. When we input -1, -1 plus 1 is 0, squared, 0, and then 2 times 0 is going to be 0. 0 plus 1 is 1, squared, that's 1, times 2 is 2. So now I'm going to plot these points on the coordinate plane. -2, 0, -2, -2, -2, positive 2, -1, 0, and 0, 2. So here is our parabola, and we know that it's been shifted left 1 because of what's inside parentheses. Okay, so functions in standard form, this is what we know them to be. This should say squared. Okay, the standard form of it is what we're used to seeing. A, in parentheses we have x minus h, quantity squared, plus k, where h and k is the vertex, and the line of symmetry is x equals h. So when we graph using standard form, it's determined, first we want to start by determining if the parabola is opening upward or downward. Then we want to find the vertex. Then we want to find any intercepts, x-intercepts, y-intercepts. And then we plot those points. So let's take a look at an example. Okay, so in this example, this should say squared. And then this should say plus 4. Okay, so in this particular example, based on what we said a moment ago, we want to start determining how the graph opens. So I know because of this negative, the graph is going to open downward. So maybe just start by identifying that. The first thing that we want to note is opens down. The second thing we want to note is the vertex. So is it in the form of h and k? Well, this is h and this is k. Remember, what's inside here has opposite signs, so that's going to be -2, and this is the direct sign, that's +4. So the vertex is negative 2, positive 4. And the third thing we want to do is we want to identify any x or y intercepts. So I'm going to start by letting the function equal 0. And now I'm going to solve for x, and that's going to be my x-intercept. So we're going to subtract 4 from both sides. Then we're going to take the opposite signs. Now I'm going to take the root of both sides. Remember, when you do that, you take plus minus. So here we're going to have plus minus 2, and here we're going to have x plus 2. So we have 2 intercepts. So if it helps you break them up, x plus 2 equals positive 2, then we have x plus 2 equals negative 2. Subtract and we get 0. Subtract here and we get negative 4. So I have 2 x-intercepts. The next thing I want to do is I want to solve for my y-intercept. So I'm going to go back here and write y equals negative 0 plus 2 quantity squared plus 4. Then we're going to simplify that. So 2 squared, that's 4, but I have a negative, so that's going to give me negative 4 plus 4 because my negative is on the outside of the parentheses here. So my y-intercept is 0, just like here. So this is probably where this is related to. And the last thing we're going to do is we're going to plot those points. So let's go over to our graph, and we're going to plot 0, negative 4 for x-intercepts. And for our vertex, we said that that was negative 2, positive 4. And then we just connect the dots. Okay, here's another example. So we're going to walk through all 4 steps just like we did in the previous example. And again, this should be squared. So first, just by looking at it, I note that because it's positive leading coefficient, that the graph is going to open upward. So let's note that opens up. Okay. The second thing I want to know is the vertex, which is, remember, opposite sign to what's going on in here, so that's 3, negative 4. And something I didn't note in the previous example was this is the axis of symmetry, so x equals 3 is the axis of symmetry. So whatever x is on your vertex is your axis of symmetry. Okay, then from here we want to identify the x and the y-intercept. So I'm going to start by letting y equal 0. Bring the 4 over. Take the square root of both sides, so that's going to be plus minus 2 again. X minus 3. So we're going to have 2 solutions. Again, if it helps you, break that up so that it's easier. So x minus 3 equals 2. X minus 3 equals negative 2. So here x equals 5. And here x equals 1. So those are my 2 x-intercepts. And then we want to find our y-intercept. So let x equal 0. And now we're finding y. So 0 minus 3, quantity squared, minus 4. Negative 3 squared is 9, minus 4 is 5. So y equals 5. So now we're going to plot our vertex, our 2 x-intercepts, and our y-intercept. So let's start with the vertex at 3, negative 4. Our 2 x-intercepts at 5 and 1. and our y-intercept at 5, and then we just connect the points. I can also just want to note that our axis of symmetry is right here. So remember, anything that, if we have symmetry, it's the flip on the opposite side. So here I can use symmetry to plot my next point. That should be right here. And now I can graph my parabola. Okay, not too good of a curve. Okay. If we don't have an equation in standard form, we can put it into standard form. Again, this should say to the second power. So if we're in this format, ax squared plus bx plus c, we're going to do this by completing the square, so long as that our leading coefficient a is 1. If it's not equal to 1, if it's not 1, we're going to have to factor it out. And then we complete the square in order to put it into this format, a x plus h squared plus k. In this example, the instructions say write the function in the standard form, identify the vertex, axis of symmetry, x-intercepts, and then we're going to graph it. So here our leading coefficient is 1, so when we group these two terms we don't have to factor anything out, and again this should say squared. So we're going to group x squared minus 14x, and then we're going to write plus 54 here. So now we complete the square. When we're completing the square, we're going to take half this term, which is 7. We're going to add it here after we square it. But remember, you have to keep it balanced. So if I'm adding it here, then I'm subtracting it here. So now when I factor this as a perfect square trinomial, I have x minus 7, because that's the term that I took half of, squared. Always the number that you take in half and that you're putting over here is the number that's going to go in here. I know 7 squared is 49, so now I'm going to take the difference, and that's 5. So that's going to be plus 5. And that's how you put it into standard form. In the next video, I'll finish the rest of this example.